Hi there, my name is Meredith Seeley, and I'm a PhD candidate and Freeman Family Fellow at the Virginia Institute of Marine Science. I was awarded the Freeman Family Fellowship to provide research and outreach on the issues surrounding plastic pollution in our oceans. That's why I'm here with you today, to share some of my research with you. I study the effects of microplastics, or the small bits of plastics that are in our environment, and how they affect marine organisms. Today, I'd like to give you some background on how microplastics can and might be affecting different organisms that we care about in the oceans. I'm sure that you've seen and heard about plastic pollution in our news and media. If you have, you've probably seen images like this. On one side, we have a sea turtle that's been entangled in a fishing net that was lost or discarded at sea, and it likely can't escape without our help. On the other side, we see a seabird that ingested too many pieces of plastic at sea and now wasn't able to digest them and ultimately died because of this. This is because plastic pollution is so pervasive in our environments. For example, this is a beach that I visited in Alaska with Chris Pallister here, who's the president of the Gulf of Alaska Keepers Association. They go to remote beaches in Alaska where debris washes up throughout the entire Pacific Ocean. For example, on this beach, no one lives within miles of here, but there's a lot of debris that we can even recognize what some of it is. I see a heap of water bottles that we've sorted through. There's a laundry hamper in the back, some fishing buoys, and even a coffee canister. So these are things that we're used to seeing in our everyday life, but are now showing up on our beaches and in environments that we care about. This part of plastic pollution is relatively simple to understand what these pieces of plastics are, but it gets more complicated. For example, on the back side of this beach, smaller pieces of plastic accumulate called microplastics. This is an image of that same beach where you can see these small bits of plastics mixed in with natural debris from the environment. These microplastics are already more difficult to understand what their effects might be because they're so small. They can be ingested by a wider variety of organisms, and we also don't know what type of plastic it is just by looking at it. And this is even more complicated than it might sound. To share with you some of these complications, I'll invite you to my imaginary ocean. And in my imaginary ocean, I'm very lucky because I only have one microplastic polluting. This microplastic, however, can interact with a lot of different things. First, it's important to understand that a microplastic, or any type of plastic, is composed of the polymer, like we hear about or we use for recycling numbers, such as PVC or polyethylene. But there are also these chemicals inside called plastic additives. Many times these additives are toxic, such as flame retardants, but they're thought to stay within the plastic and not be toxic until they start to break down. Of course, microplastics have broken down from bigger bits of plastic, so we wonder about what's happening with these additives. In addition, there are a lot of pollutants that are already in the water from a variety of other human activities. Because those pollutants are usually so hydrophobic, or they don't like to be dissolved in water, when plastic is introduced, they will stick to the surface of the plastic. So now I have a microplastic that's not just this plastic polymer, but you can see that it's composed of these chemical additives, as well as pollutants that it might be stuck to the surface from the surrounding water. The effects to organisms such as these fish can be varied. One thing we're curious about is if they ingest plastic, do they hold on to any of these pollutants from the water or any of the additives during the digestion process? And do those wind up in their tissues and cause toxicity issues? Or do additives leak into the water during degradation of plastics, ultimately making their way into the tissues of the organisms we care about? Some of the organisms that I care about are the smallest organisms in our systems, bacteria. Bacteria are really important, and I'll remind you of the food you eat to explain why. When you eat a slice of pizza and it goes down through your gut, the bacteria in your stomach and your digestive system digest this pizza and provide nutrients to your body. And this keeps your gut healthy. This is why we take probiotics, or probacteria you could think of, to help supplement these bacteria and make sure they can digest our food and give us all our nutrients. The seafloor works the same way. There's sediment in the sediments, or the seafloor, there are bacteria. And when organic matters such as dead plankton, feces, or even now plastic rains down from the surface waters to that seafloor, it's processed by those bacteria, which provides nutrients to the entire water. And this keeps our waterways really healthy. But of course, plastic is a new contaminant in these systems, and we don't really understand how it will affect this bacteria. To address this issue, I did a research study at VIMS where we did a microcosm experiment that looked something like this. Essentially, we took clean sediments with bacteria in them, and we added different types of microplastics to each of these jars, ×3, to make sure we knew what was happening. And these different types of microplastics are very varied in their polymer structure, their additives, and all sorts of things. We then analyzed and wanted to understand if there's bacteria in the sediment normally, like we see here, and we add plastics, will those bacteria change, the types of bacteria that are there, and hence the type of nutrient processing that's going on? We found that not only did this change, but also if we added different plastics, the bacteria changed in different ways. So this affects the health of our waterways in the way that nutrients are provided from our sediments to our overlying water. And we're finishing up this research now to really understand what this means for our area, the Chesapeake Bay, and the world. So how is plastic pollution affecting the marine food webs? Of course, I just told you that it might be affecting bacteria that process nutrients in our sediments. Plastic can also expose organisms to a variety of other contaminants. And of course, ingesting bits of plastic, even microplastics for certain organisms, can cause intestinal blockage and ultimately death. Thank you so much for tuning in with me today. If you'd like to get in touch or learn more about my research, feel free to email me or find me on Twitter at Meredith_Seeley. And of course, the best way to stay in touch with VIMS is to sign up for the eTidings monthly newsletter. This newsletter shares with you all sorts of events that are happening at VIMS, both virtually and in person. For example, if you're interested in more topics on plastic pollution or to learn more, check out our After Hours lecture site where you can find recordings of a lecture on this and many other topics. I hope to see you again soon.